New images captured by the James Webb Space Telescope have surprised researchers rather than reinforcing our understanding of the universe. These images revealed a disturbing fact: our current physical understanding is not sufficient to explain the nature of the cosmos in its early stages, where the Big Bang theory reaches its limits. This forces us to consider new hypotheses about its origin. The question arises as to how the universe was formed in detail and why this new discovery challenges even the most experienced astronomers. Find out with us more about the Big Bang and the revolutionary details of the discovery. Before we get into the details, let's recall for a moment the concept of the Big Bang, which is often mentioned to describe the creation of the universe. Contrary to common belief and some reinterpretations, the Big Bang was not an explosion in a pre-existent space. Rather, it was space itself that originated approximately 13.8 billion years ago, along with matter and time, from an original singularity. To clarify in simpler terms, in the field of physics and astronomy, singularity is a term used to describe places where gravity is so intense that the curvature of spacetime becomes infinite. But how can we be so sure about all this? Today, after billions of years since the beginning of the universe, we find that our cosmic home is formed as a part of a fundamental process. For experts, this represents an intrinsic feature of the universe since its very existence, its seemingly endless expansion. However, it is crucial to understand that the cosmos is not expanding into a precise space, rather, the space itself is constantly increasing in size. If we follow conventional theories, it is estimated that the first stars began to shine between 200 and 300 million years after the Big Bang, marking the end of the so-called Dark Age when the first luminous celestial objects clustered together to form mature galaxies. However, how fast these galaxies grew is still an unsolved enigma. An important clue to solving this galactic enigma emerged through the first images captured by the James Webb Space Telescope in July 2022. Experts announced that the telescope had detected a number of galaxies, some of which had already existed some 300 million years after the formation of the universe. However, compared to the galactic structures that developed millions of years later, these early galaxies remained considerably smaller and less massive. This fits perfectly with the scientific model accepted by researchers. The density of matter in the young universe was simply not sufficient to give rise to galaxies of the size of the galaxies we observe today. What began as the discovery of 6 bright redshifted luminous spots apart from James Webb turned out to trigger one of the most significant astronomical crises of recent times. Now, although these newly discovered galaxies are similar in age to previously recorded galaxies, they are almost as massive as our own Milky Way galaxy. This has led to an intriguing mystery through astronomical research, thanks to a team from Schmoor University of Technology in Melbourne. After examining a series of images captured by the near-infrared camera, the researchers finally identified the previously mentioned light sources using redshift. The scientists calculated that the light from these objects took more than 13 billion years to reach our eyes on Earth. Consequently, we are dealing with structures that had already existed between 500 and 700 million years after the alleged Big Bang. By analyzing the characteristics of these structures, it was concluded that the Webb telescope had captured 6 extremely early galaxies in the image. Surprisingly, these galaxies were so massive that they defied conventional expectations of cosmology. Instead of finding the expected dwarf galaxies, structures were identified that were almost as massive as our own Milky Way galaxy despite having formed at an early epoch. If we continue to analyze the data collected by the James Webb Telescope, this gravitationally bound grouping of stars was already more than 10 billion times the mass of the Sun at that time, and one of them may even have surpassed the 10 billion solar mass mark. However, even if this possibility is considered, the history is still not complete. Completely solved, even in this scenario, there would be significantly more stellar mass in the early universe than previously assumed. Since shortly after the Big Bang, there was not enough abnormal matter available to form so many stars in such a short period of time. The detected objects contradict virtually all conventional cosmological theories. Even if only one of these galaxies turns out to be genuine, it would go beyond the limits of our previous assumptions to explain the existence of these structures. Furthermore, the density of matter in the early cosmos would have to have been up to 5 times greater than previously assumed in order to explain this phenomenon. Another equally mysterious explanation is based on the fact that these galaxies developed in a way that is still completely unknown to us. These discoveries and the debate surrounding the Big Bang are leading more researchers to move away from this theory. Many astronomers with more alternative views are frustrated that they are not being heard in scientific journals. Even those who express doubts about existing theories are often labeled as unfounded eccentrics. However, it is undeniable that even experts who still defend the Big Bang theory are constantly faced with questions without clear answers. These questions include particular issues such as why and how 13.8 million years ago something literally came out of nothing. Can something really originate from nothing, or was there something triggering event, or was it all just a coincidence? Stephen Hawking pointed out that the concept of time as we know it began only with the Big Bang. Therefore, this process could not have been triggered by something external. A similar controversial question relates to the uniformity of radiation and density throughout the cosmos. No matter in which directions or at what distance we look on a larger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conservative scientists explain this theory by the theory of cosmic inflation. However, other experts take this assumption and take it a step further with the theory of chaotic inflation. According to this idea, it is possible that this process has stopped only in some regions like bubbles and continues infinitely elsewhere. This implies that multiple universes form in these bubbles, each with its own individual physical laws. Considering this context, a fundamental question arises: what if the cosmos does not represent the complete whole, and even more, if another universe existed before ours? In that case, the Big Bang would become a great cycle. Following this theory, concepts like beginning and end are ambiguous in a cosmic context. What we usually refer to as the Big Bang could have been simply a transition in a continuing cycle. As soon as this universe exists, a new one emerges from it. According to this perspective, our universe is part of a larger multidimensional structure. Within this model, the idea of an external cycle of collapse and rebirth of the universe is put forward. However, this is not the only perspective presented in the field of cosmology. Apart from the Big Bang theory, in 1955, for example, an article appeared in NASA's Cosmic Times arguing that there may have never been a Big Bang since the universe has existed for an infinite time. In this view, the expansion of the cosmos would be non-existent, and the continuous formation of matter could give the impression of a constant expansion of the universe. Another intriguing though controversial theory comes from the world of quantum physics and string theory. Supposedly, some experiments have suggested that our universe and everything in it does not actually exist. In simple terms, what we perceive as a visible universe could simply be a flat hologram projected onto a sphere. Therefore, there is a possibility that our reality is a result of a higher stimulation. While this may sound like the plot of a fanciful science fiction movie, it can be connected to the Kardashev scale. The scale is used to measure the level of development of a civilization according to its ability to use energy. If there were a Type 3 civilization capable of fully harnessing the power of an entire galaxy, it could have created a perfect simulation. However, finding out the truth in such a scenario is a very complicated matter. Do you still believe in the Big Bang theory, or do you consider alternative explanations more plausible? Let us know your opinions in the comments box. If you liked the video, don't forget to hit the like button, subscribe to the channel, and share this video to reach more people. Thank you so much for watching, and I'll see you in the next one.